Hey guys, welcome to Microsoft Student Chapter VIT-AP's YouTube channel. Here's to another video of Inheritance Part 2. In this video, we'll see at the types of inheritance in Java. So basically in programming, there are five types of inheritance, the concepts of five: single, multi-level, hierarchical, multiple, and hybrid inheritance. Though in Java, we only support single, multi-level, and hierarchical inheritance to the extents keyword. The multiple inheritance and the hybrid inheritance concept can be achieved, but they can be done with interfaces which will be covered in the later chapters. So we'll look at single inheritance. Single inheritance is a specific type of inheritance in object-oriented programming where a derived class inherits from only one base class. It's the simplest form of inheritance and considered the most straightforward to understand and implement. In the previous video, we've looked at the example of class employee and the class programmer, remember, right? So basically that is it. Here, there, the class employee is the base or the parent class, which here in this image is class B, and then the class programmer is the child or the subclass here, which is class A. It is simply inheriting the properties of the employee into the programmer. That's it. That is single inheritance. In multi-level inheritance, it is a multi-level inheritance in object-oriented programming is a way to create class hierarchies with more than two levels. It builds upon the concept of single inheritance. If you look at single inheritance as single level concept like ground floor and first floor, multi-level inheritance has multiple floors to it. Multiple levels of inheritances are happening. See, look at here. Base class, intermediary class, and the derived class A, B, and C. Now we'll look at a simple example for you guys to better understand. See, here the base class animal. I've created a class animal and I've given a method eat to it, a function. In this, we'll see animal is eating, we'll print out something like that. And here class dog is extending the class of animal. Look at here. So animal becomes the parent class and dog is the first level of inheritance here. And then again, we'll give something like dog barks, right? So function as void bark, public void bark, and dog is barking, and poodle, the puppies. So puppy will inherit the properties of both dog and also the animal, but you don't have to write both dog and animal over here. If you just write poodle extends dog, because already dog has inherited the properties of animal, poodle will automatically inherit the properties of animal by extending dog, right? So that's exactly. So poodle is dancing. And here in the main method, I've written as I've created an object of poodle and poodle eat, poodle bark, and poodle dot dance. I've implemented all three functions over here. If you can check the output over here, see, animal is eating, dog is barking, and poodle is dancing because given poodle dot eat. Even though poodle dot eat is eat function is not here in the poodle class, but as it is extending, as it is inheriting the properties, the attributes, the methods of the superior parent class animal, therefore we can see the output animal is eating from here. And similarly, poodle dot bark. We haven't mentioned bark function in the poodle class, but it is in the dog. So poodle dot bark will give dog is barking, and poodle dot dance, as it is already there in its own class, it will give. Here, if you try and write uh, animal dog, right? So dog t is equal to new dog. There goes the constructor creation of a new object, and then d dot bark just works fine because bark is the own function, and d dot eat also works fine because look, dog is barking, animal is eating. Because dog D extends the properties of animal, it can also give the output for dog dot D dot eat. So this is multi-level inheritance, guys. And then next we have hierarchical inheritance. Hierarchical inheritance is an object in OOPS creates a class hierarchy like a family tree. It involves one base class and many subclasses. The inheritance pattern forms a hierarchy resembling a tree. The base class sits at the top and subclasses branch out. If you see the structure of a tree, it's a tip and it grows branch by branch, right? Similarly, a base class will be extended by multiple derived classes, not like A will extend B and B will extend C, not like that. B, C, D will, all the three will extend A. That is the difference between hierarchical and multiple. If you look at see the images, you'll have a clear understanding here. And we'll also look at an example of hierarchical inheritance. Hierarchical Java. See, here class animal, I've taken the animal analogy gets me. So class animal int, I've given it an attribute int legs is equal to 4, and then I've also given it a function void eating, and it says eating dot dot dot. And then next class cat extends animal. So it also has the function of animal, and also it has its own function meow. So cat meow, so meow. And then dog extends animal bark. I have a function called bark bark bark. And in this main method, I've created an object of cat c1, and then c1 dot legs here. See, you can c1 dot legs is a attribute of the superclass, so it will also be in the child class, right? So that's why and c1 dot meow, c1 dot eating is also there. So legs, number of legs 4, and then c1 dot meow, of course it is in its own class, so it will perform the function. And then the method, the function of the parent class c1 dot eating also runs smoothly because here cat extends animal. But there's no connection here between cat and dog. So if you try and write c1 dot bark, see, you can't implement it because you're getting an error because cat and dog are not related. Both cat and dog inherit the properties of animal, but they're not related to each other. If here I create an object of dog, look at here, dog d1 is equal to new dog. Yep. And then d1 dot bark works just fine because bark as its own, and then I want to print out the number of legs it has, so d1 dot legs also works fine. Alright, I'll comment out this for see d1 dot bark and system dot println d1 dot legs 4. So this is hierarchical inheritance, guys. Multiple inheritance. Multiple inheritance, as we have talked before, it is a theoretical concept which we can apply it in Java using interfaces, which is another concept which will be taught in the next chapters, next lessons. Uh, so basically, the theory is a single class can extend multiple classes. So here, if you look at C, it is inheriting the properties of both A and B. Here we've seen that a single class can be inherited into multiple classes, but a single class cannot inherit multiple classes' properties in its own. So that is the difference between multiple inheritance and the inheritance we have right now, hierarchical. So what are the advantages and uses of inheritance? Yes. So code reusability, as we have talked before, it reduces the time for a programmer to write long codes. We can use single attributes in the superclasses and they cannot be inherited. Next, abstraction. Inheritance allows for the creation of abstract classes that define a common interface for a group of related classes. This promotes abstraction and encapsulation, making the code easier to maintain and extend. Abstraction, we've known, it is a property of OOPS, a very important property. Uh, so it encapsulates the information which is not shown, but it is very well understood and it is also easier to maintain. Class hierarchy. Inheritance allows for the creation of a class hierarchy which can be used to model real-world objects and their relationships. And next, polymorphism. inheritance also allows for polymorphism, and that is for an ability for an object to take multiple forms. So it also has its own disadvantages, guys. So complexity. When you're writing longer codes and you're inheriting on multiple levels, it is difficult to for the readability. It is more complex to understand because you have to know exactly how is it working because you have to find which class it is extending it from. So there is a complexity occurs when you reach uh, memory or length of the code. When you reach a certain point, inheritance increases complexity, and also it creates tight coupling. Inheritance creates tight coupling between the superclass and the subclass. As we have talked before, if you make any change in the superclass, it will make a difference in all the subclasses itself. So when you want to make a change only in the superclass and want to remain all the subclasses the same, you can't achieve that through inheritance. It becomes difficult. So that is tight coupling, guys. Thank you. Do visit this channel and please subscribe. Will be more.